we looked at a naive algorithm to compute prime numbers, and we found that, as the number becomes large, the algorithm tends to become very, very slow. In fact, as it turns out, there's a straightforward way to make this efficient. We need not search anything beyond square root of n. Now, why is that? Well, why is that? Well, think about it. When I find that a number is divisible by 2, or say not divisible by 2, I'm also finding out that number is divisible by or not divisible by, say, n by 2, because it's 2 times n by 2, which is n. Now, if I were to just extend this argument, you realize that, if let's say there are two factors, p and q, both obviously are smaller than the number, we cannot have both being more than square root of n, because if that were the case, p times q will become more than n. So that is not possible. It can't be true, right? So which means that if p is, let's say, more than root of n, q must be less than root of n. And a consequence of that is, look, if I have searched all numbers between 1 until root of n, I don't need to search any further, because the prime number would have been, the factor would have been detected even in that search. And this is the, let's say, the thought behind increasing efficiency, just clever use of mathematics and logic. Implement this in code. Let's get, so I'll just create a new code cell. In fact, I will take most of the algorithm from here itself. I'll just take this. Let's just, on a new cell, I'm just going to define a new function over here. Let's call it is prime, I guess, smart, right? So that, some distinction from is prime. So is prime was a naive algorithm. However, I need to import math over here. So I import math is prime n, everything else remains the same. I just go and say, okay, look, instead of running all the way from 2 to n, let me run this to, say, square root of n. Right now, this kind of easy to miss a few points here, so let's do it a little bit carefully. So I'm going to say int, say, math dot sqrt, say, n, and so this has to be +1. Now, let me just talk about this a bit carefully. Basically, math.sqrt will give you the square root, but remember, square root itself may not be a number, may not be, let's say, an integer, right? So, for example, if a number is not a perfect square, then math.square root will give me, let's say, some decimal number, right? Now, we don't want that. We want the integer part of it. However, I must go and add a +1, because if I don't do this, my algorithm no longer remains complete, no longer remains correct. Reason is this, right? So let's just see this for ourselves. I just create a new code cell to kind of illustrate this point. Let's say I go and import, say, import math, and I do math dot sqrt, say, 25, right? So if I were to do this, clearly the answer is 5.0. Now, if I were to, let's say, just to int 5.0, that will be 5. I'll get a situation here, range 2, 5. Remember, however, what that means is that, look, I will run the algorithm from 2, 3, and 4. I will not touch 5. And that's going to be a problem, because perfect square will then get classified as a prime number. So that is a mistake. Our algorithm can get, let's say, incorrect from that point of view. We don't want that to happen. Remember, the algorithm must be correct. Seeking efficiency cannot compromise with correctness, right? So from that point of view, be careful. There has to be +1 over here. But once I do that, in fact, this is really cool. So once this function is defined, I can run this once, so that the function is now available to collab. And I can, call this from another cell, even though the cell has come before. So I can just go and say, for example, is prime, say, smart, you know, and when I do this, indeed it tells me true. So this algorithm is indeed correctly done. In fact, we should, the thing to test for is, let's say, a perfect score. But if I were to try, for example, let's say 25 is a really good example, right? So if I were to try 25, and if I did not have a +1 over here, right? Very interesting, very easy to make this mistake. If I were to do this now, this will be declared as a prime number. Now, reason, like I said, is because 5 is not being checked here, right? So we don't want that. That's why I had a +1 over here. When I do is prime, okay, so I have to run this again. So, and then I can run this. Indeed, 25 is not a prime number. So, this algorithm is correct. Just be careful about this, the way this whole thing is set up, right? We'll come back and look at quantifying how much efficiency we have gained through this by running a large number through this and analyzing the result, because that's where the insights will come from. I hope you found this interesting. in the algorithms and Olympia track. This is the kind of studies we are doing on algorithms. Look at our website www.yby.in. You'll enjoy programming.